Okay, so get this. We all know there are 3 dimensions, right? Like up, down, left, right, forward, back. Simple.
Yeah.
But what if I told you that scientists were able to put light particles into 37 dimensions at the same time?
Wow.
It sounds crazy, right?
Yeah.
37 dimensions. We're going to be diving into a paper that was published in Science Advances, and it was actually explained really well in this article on Enseñame de Ciencia.
Okay.
And honestly, just reading this, my brain kind of went like, what?
It's a lot to take in.
Yeah. So how can something exist in 37 dimensions? I mean, is this even real? It sounds like we're talking about science fiction.
Right. It does sound like science fiction.
Yeah.
But this is actually hardcore physics.
Okay, so help us understand this.
Yeah.
So the article talked about this team of Chinese physicists.
Right.
And they did this experiment, and it's honestly pretty ambitious.
Yeah.
But I guess my first question is, how is this even possible?
So to understand this, we kind of have to take a step back and look at the 2 big theories we have in physics. So we have general relativity, which explains really big things, so planets, gravity, that kind of stuff.
Okay.
And then we have quantum mechanics, which governs the really, really tiny world. So we're talking atoms, particles. And the big problem is that these 2 theories, they don't play nice together.
Okay, so they clash.
Yeah, it's like trying to fit a square block into a round hole.
Gotcha.
They just don't work. And so what this experiment is trying to do is to see just how different quantum mechanics is from the physics we see every day.
Okay, that makes sense. So that's kind of the motivation behind why they did this, but how did they actually get these photons into 37 dimensions? So photons are light particles, right?
Yeah, photons are particles of light.
So how did they get them to be in 37 dimensions? Did they build some kind of portal in their lab?
So it's not about physically going to another dimension.
Okay.
It's more about describing how complex the photons are. So think about it this way. If you were trying to describe a color to somebody, you would need more than just one word to describe it, right?
Yeah.
You'd have to talk about the hue, the saturation, maybe the brightness.
Yeah.
So it's kind of like that. You need all those different pieces of information to really capture what that color is.
Okay.
And that's kind of what's happening here with these photons.
Yeah.
They need 37 different pieces of information to fully describe their quantum state.
Okay, so it's not a portal. It's more like needing a really long code to tell you what this photon is doing.
Exactly.
Gotcha. Okay, so to understand why this is a big deal, we kind of have to talk about something called the GHZ paradox.
But the GHZ paradox.
Which sounds very intimidating.
It sounds very complicated.
Yeah.
But we can break it down and make it make sense.
Okay, good. So what is it?
So basically a thought experiment. It was developed back in the late 80s by physicists Greenberger-Horne-Zeilinger.
Okay.
And it demonstrates that the quantum world can produce results that just don't make sense in our classical world.
So does that mean 1 + 1 = pineapple?
Well, maybe not that extreme.
Okay.
But it's definitely a head scratcher.
Okay.
So imagine you're flipping a coin and you get heads and tails at the same time.
Uh-huh.
It's kind of like that. It's that level of weirdness, and it highlights the non-classical behavior of quantum particles.
All right. I think I'm following so far. So we have these 2 theories of physics that don't work together, and this experiment is kind of probing that difference and putting these photons into this really complex state that we're calling 37 dimensions. But how did they actually do that? What were they doing in the lab?
Right. So in the lab, they used something called coherent light.
Okay.
Which is kind of like a laser. And so imagine you have a marching band and everyone's perfectly in sync, every footfall hitting the ground at the same time.
Yeah.
That's kind of what coherent light is like. All of the light waves are moving together, and it allows scientists to control the photons really precisely.
Okay, so they use this laser-like light to get the photons into this complex state. And that's how they get to 37 dimensions.
That's how they get to 37 dimensions, yeah.
Okay, and by doing this, they were actually able to observe some of the most non-classical quantum events that we've ever recorded.
Right, they're really pushing the boundaries of what we thought was possible.
So they're pushing boundaries, but what does that mean for us? Why should we care about photons being in 37 dimensions? What's the takeaway here?
That's a great question.
Yeah.
And to understand the answer, we really need to zoom out and look at the bigger picture.
Okay.
Because this isn't just about abstract physics. This actually has the potential to change the world in some really tangible ways.
Okay, so how could this change the world? What's the big deal?
Well, imagine if these high-dimensional quantum systems, since they're so complex, imagine if they're way more stable too,
okay,
and way less prone to errors, right?
Uh-huh.
Think about it. What if your phone battery lasted for weeks?
Oh, wow.
because quantum computers designed this way just need so much less energy.
Are you saying this could lead to, like, those super powerful quantum computers we always hear about?
Yeah, I mean, it's definitely a step towards that.
Wow.
We're talking computers that could just, like, blow away the problems that would take our computers now, like billions of years.
Yeah.
Problems like designing new drugs that could, like, save lives, creating new materials, or just understanding the universe in a whole new way.
Okay, that sounds pretty amazing. But all this quantum computing stuff always feels so far off.
Right.
Like it's always coming soon, but never actually here.
It's true. Quantum computing is definitely still in its early stages.
Yeah.
But research, like, this is what's pushing it forward, you know?
Okay.
And it's not even just about computing. Imagine using these high-dimensional systems for communication.
Okay.
Think about how hard it would be to crack a code based on 37 dimensions.
Yeah, that sounds pretty impossible.
It'd be like having a secret language that only, like, you and the recipient could understand.
So we're talking like super secure communication.
Yes.
Like unhackable networks, basically.
Yeah, pretty much.
That's huge. Okay, so earlier you mentioned something about this helping us understand the universe better.
Right.
How does that fit in?
Okay, well, remember how we talked about the two big physics theories? Relativity and quantum mechanics.
Yeah, and how they don't get along.
Exactly, they don't get along. Well, some physicists think that figuring out these high-dimensional systems could be the key to finally putting those two theories together.
So you're saying these photos in 37 dimensions could help us solve one of the biggest mysteries in physics?
That's the idea, yeah.
Wow, that's a big claim.
It is a big claim.
Yeah.
But that's what makes it so exciting. Like, what if our universe is way stranger than we thought?
Yeah.
And what other secrets are hidden in the quantum world, you know?
I mean, it's fascinating, but also kind of overwhelming.
Yeah.
37 dimensions, it's kind of hard to even wrap your head around.
I know, it's definitely outside our everyday experience.
Yeah.
But remember, these dimensions, they aren't physical places, right? They're more like mathematical tools that we use to describe how these photons are behaving.
That makes sense. But it still makes you think, like, what else is out there that we just can't even see or perceive, you know?
Absolutely. That's what's so cool about science.
Yeah.
It's always pushing the boundaries of what we understand, and it's opening our eyes to all these new possibilities.
I mean, we might not be able to actually experience those higher dimensions, but at least we can, like, appreciate how clever these scientists are and the amazing things that they're discovering.
Yeah, absolutely.
So we've talked about the experiment, the 37 dimensions, what that even means, the implications for quantum computing, secure communication, and even our understanding of the universe.
It's a lot.
It is a lot. What are your final thoughts on all of this?
Yeah, it is a lot to process. We started with 3 dimensions.
Right.
And now we're talking about photons existing in 37. It really makes you wonder what else we might be missing, right?
Absolutely. It makes you realize we really don't know that much about the universe. Yeah, and we like to think that we have it all figured out.
Right.
And then something like this comes along.
Exactly.
Blows everything we thought we knew out of the water.
Totally.
Like the more you learn, the more you realize you don't know.
Yeah.
And what we're learning here is that reality is way weirder than we thought.
It's true. Yeah. And this experiment, with its 37 dimensions, is really just the beginning.
Yeah.
It's opening of so many doors for exploration in physics, computing, communication, even philosophy. We're talking about changing how we understand reality itself.
Wow. So what do you think is the biggest takeaway for our listeners? What should they be thinking about after all of this?
Honestly, I think the biggest takeaway is to just be open to the unknown. The universe is full of mysteries, and trying to solve them is what makes it so exciting. We don't have all the answers yet, but experiments like this one show us that there are so many possibilities.
That's a great point. And who knows, maybe someday, because of research like this, we'll be able to experience those higher dimensions ourselves. But until then, I guess we just have to marvel at how clever these scientists are and let their work inspire us to keep asking questions, keep exploring, and just keep pushing the boundaries of what we think is possible.
I like that.
Well, thank you so much for guiding us through all of this.
Oh, it was my pleasure.
And to all of you listening out there, we hope this deep dive has left you feeling a little bit more curious about the universe. Keep those brains buzzing, and we'll catch you next time on The Deep Dive.